Hello there. From this class, we are going to actually start the learning in digital computers and DLD. So this is going to be the second class in our DLD course, but I would say this is the first class. This is the introductory class where we will discuss what digital computers are, because DLD is implemented in digital logic and design is implemented in digital computers. So first of all, we need to understand what a digital computer is. Now we all know about a computer. A computer is what? It is electronic device. We don't call a computer electric device, we call it an electronic device. And I have told you in my other videos that we call it electronic device because it is using some electronical components like transistors, like ICs. All of those are electronical components. So most part of the computer is comprised of semiconductors and electronic components. So that is why we call our computer an electronic device. So now we have we have appended one more word with the word computer, which is what? Digital computer. Now you might have heard of analog computer and digital computers, so I will try to make a difference in this class between the analog and digital computers. So digital computers are what? These are those computers which deal with the actual form of data that we currently know in this era. We know the data like images, like videos, audios, and other data like text data. All of these data are generally called the digital data. So what is the purpose of digital computer? Digital computer processes data in the form of digital signals. So simply here we deal with digital signals, and just like the previous video I shown there too, 1 and 0 are the digital signals. There are only two type of signals in digital media or digital communication, and that is what? 1 and 0. We can only use these two signals when we are using a digital computer. So simply these data are also made up of these things, and the signals are also made up of these things. So another property of digital computers is that they represent and they manipulate the information that we use in discrete form. Generally we call it binary form or machine language form. So simply the data that is dealt by the digital computers are in discrete form. Now this thing would be cleared from this diagram. Now as I told you, we also have some analog computers and then we have some digital computers. Now if you will see the diagram of digital computers, you would see discrete diagrams here, or discrete part of my diagrams here. Now look, here is one, and then here will also be one. These are zeros, if you can see. So there are discrete points, defined points here. Look, these are discrete defined points. If there is something, it is here. If there is nothing here, then there is nothing here. As I can see, that is considered zero, just like here, just like here. And in physics we normally call the one as high, we name them as high and low. So generally if you will see this diagram, you will understand the discrete nature of digital computers. On the other hand, some data are analog, just like temperature and all these things. Now they form a graph like this, which will be continuous, non-discrete. Normally these are real numbers, these values that we acquire. Let's say if I'm talking about a thermometer which is trying to measure a temperature, so temperature is never a discrete entity. We can't give a discrete temperature. Normally we say that the temperature is 36, but it is not actually 36. It is not actual. We are not pointing towards the exact point. That may be 36 point something, but we are not pointing towards the exact point. So that is why we call it temperature. Is what? Temperature is a continuous entity, and for dealing with such kind of quantities we use analog computers, and digital computers are used to process data in digital form, or those data which are simply in the form of 0 and 1. Now digital computers generally comprise of, as I told you, electronical components, and from electronical components we normally the word electronics that is used here. So electronics is generally the actually the branch of physics where we study about semiconductors or semiconductors. So normally there are multiple semiconductors, but normally in computers we only use silicon, mostly use silicon. So that is why we call a computer electronical computer. Now electronical computer has some electronical components. One of some of the most common components there are transistors and ICs. You might have heard about these components here. These are actually electronical components, but these won't be necessary for a normal user to understand. A normal user doesn't need to know about the transistors or the electronic components or chips inside the computer. Now what does the user or the high level user thinks about computer? From the high level perspective, we can divide the computer in the following components. Now we have a control unit here. Normally this area is considered as our CPU. This will be our CPU, and then these are the memory units that we have. It contains our RAM and our secondary memory, and then we have some peripheral devices which are input device and output device. All the mouses and other things come in this category. Our RAM, our ROM, our other secondary storage devices like hard disks and SSDs come in this category. And then we have our processor. Actually this is also a part of our processor. So this is a generic structure of computer. Now if you are familiar with the inside components of computer, you might know about arithmetic and logic unit, ALU, which is responsible for performing some arithmetic or logical operations inside the CPU or mathematical operations. Then there is the control unit, which is used to which controls all the operations inside the processor or outside the processors. There are also some registers inside the processor which are used to store data for temporary storage. So these are some components of computer. I've picked this diagram, I've copied this diagram from the book that I mentioned to you guys in the last class, which was Mano's book, Digital Logic and Computer Design. So this was just a brief introduction about digital computer. I know most of you guys know about this thing, but as I'm trying to go with a sequence, so that is why I created this video about digital computers too. So in the next class we will be studying number systems like binary number systems and other number systems. We will try to wrap them up as soon as possible there, because there are not that much important things that we are going to be studying in this course. So I think this is enough for this class. In the next class we will discuss some more sophisticated and more important things. Thank you.